All right, so obviously then lesson 6.6b is all about how do we find our horizontal asymptotes when we do not have them written in the form where we can see transformations. So then by this lesson, you should be able to identify horizontal asymptotes, obviously, but now in a different way when we don't have them in the form where we have transformations. So it says graph the following function on your calculator, write the equation of the horizontal asymptote. So obviously you are going to have to go to your calculator and you're going to have to type in y equals, right, y1 in parentheses 2x squared plus 8x divided by parentheses x squared minus x minus 2. And then you hit graph. All right, so you guys should be seeing on your calculator, right, a value for x that both of your that your graph approaches, right, a horizontal line. Now remember, horizontal asymptotes we can cross. So kind of look at what you see here, what you see your graph getting closer and closer and closer to. Okay, well, I see it being at y, sorry you guys, I couldn't find my pen, here we go. So it's at y equals 2. Example 1, what was true about the degree of the top? So degree is 2, and on the bottom, the degree is 2. All right, so they have the same degree, and we got y equals 2. Well, my leading coefficient of my top is 2, and my leading coefficient of my bottom is 1, and 2 over 1 is 2. Okay, well, let's see. Let's see if that... All right, so now let's graph this one. Let's graph y equals, we're going to do 2x squared plus 8x, but this time we're going to divide by x cubed. Okay, and I'm going to hit graph. All right, I'm looking here. Let's see here, what do we have? Trying to figure out, I've got my graph, so I'm just doing some tracing and trying to see my y values. So I see that it is approaching y equals 0. Perfect. Now, an example we see here. Here we had what? My degree on top was 2, and on the bottom it was a degree of 3. So the degree of my numerator was less than the degree of my denominator, and I got y equals 0. Last one, let's see, we're going to take x cubed. Go clear this out, sorry. X cubed divided by, divided by 3x squared. Oh. All right. I don't see any. This is the equation of a line. I don't have any horizontal asymptotes. There aren't any. So, and then what about my last one? Here, the degree of my numerator was bigger than the degree of my denominator, and I got none. It says, look at the degrees, right? Look at the degree of your numerator and your denominator, and what you then got for your horizontal asymptote. Okay, so take a look. So, degree of our polynomial. So, here's what we know. Hold on one second. So, if degree of numerator is less, well, you guys, I can't write all this. I'm just going to make it a little simpler. Okay, so if the degree of numerator is less than the degree of the denominator, you have a horizontal asymptote at y equals 0. If the degree of your numerator equals the degree of your denominator, your horizontal asymptote at y is at y equals leading coefficient of numerator over the leading coefficient of denominator. This is actually a C. It doesn't look like it, but that's an O. And then if you have the degree of your numerator is greater than the degree of your denominator, you have none. You have no horizontal asymptotes. So let's take a look. Degree of my numerator is 1. Degree of my denominator is 1. So the degree of my numerator and my denominator are the same. So y equals, what is the leading coefficient of my numerator? It's a 2. Over what's the degree, or what's the leading coefficient of my denominator, and it's a 3. So y equals 2/3 is where my horizontal asymptote. Okay, here the degree of my numerator is 1. The degree of my denominator is 2. So the degree of my numerator is smaller than the degree of my denominator. So I have a horizontal asymptote at y equals 0. Last one, the degree of my numerator is 2. The degree of my denominator is 1. The degree of my numerator is bigger than the degree of my denominator, so there are no horizontal asymptotes.